Hello, everyone, and welcome to today's webinar, How Utilities Can Scale Digital Twin Programs. We're excited you could join us. My name is Chris Warren, and I'll be moderating today's event. Today, we're going to delve into digital twins, a topic that many utilities are eager to learn more about. We know that's the case because many utilities have pursued pilot deployments of digital twins. All too often, though, pilots have been the end of utilities leveraging digital twins, rather than the beginning. Our guests today are going to explain why that's the case and how to overcome the challenges to scaling digital twins. We're also going to hear directly from PG&E, which has managed to move beyond the pilot phase to a robust deployment of digital twin technology and is enjoying the benefits of that effort. We're thrilled to be joined by three speakers today. First, Michael Susinski, who's a senior manager, T-line engineering for Pacific Gas and Electric, or PG&E. Also joining us is Andrew Davies, vice president, strategic accounts for EKN Engineering. And finally, Jeremy Frint, utility engineering and practice lead, also for EKN Engineering. Before we get started, I have just a few housekeeping items. Please note the slides will advance automatically throughout the presentation. To enlarge the slides, click the Enlarge Slides button, located in the top right corner of your presentation window. If you need technical assistance, click on the Help widget, located on the bottom left corner of your console. We encourage you to submit questions at any time throughout the presentation, using the Q&A widget at the bottom of your console. We'll try to answer these during the webcast. But if a fuller answer is needed or we run out of time, they'll be answered later via email. Please know that we do capture all questions. Now to kick off, I'd like to ask each of our speakers to quickly introduce themselves and their work. Michael, can you get us started?
I'm Mike Susinski. I'm Senior Manager for Transmission Line Engineering for Pacific Gas and Electric. Been with the company 10 years.
Great. Thanks, Michael. And I'll try calling you Mike from now on. Andrew, can you give us a little bit of background about yourself, but also EKN Engineering as well?
Sure. EKN Engineering provides civil and utility engineering services to clients with a focus on integrating engineering, technology, and software. And we try to do that in a way that minimizes disruptions to existing operations. And what that means is we bring solutions that can integrate into existing systems of record and technology that's built or modified specifically for the client's needs. Some of those include asset health, which is provides real-time data integration and analysis for proactive management to identify maintenance needs. Second is work bundling, which is an effort to combine and coordinate work plans across lines of business to reduce redundancies and gain efficiencies, kind of streamlining operations and mitigating site visits. And then finally, quality management, which is a process to collect and verify field data, which is used to update and maintain a digital twin. As partner in a VP of strategic clients, help in all those aspects and anything else that the client may need.
Thanks, Andrew. Finally, we're joined by Jeremy Frint, who's also with EKN Engineering. Jeremy, can you introduce yourself?
Yeah, hello everyone. A little background about me. I've been in the utility industry for a little over 10 years, designing transmission lines, working with everything that you'd imagine with a transmission line engineering role. Currently the utility engineering practice lead at EKN, so my role there is really asset management, asset health, monitoring and gauging ways to evaluate and provide information to Mike and others to make their decisions and recommendations based on data.
Terrific. All right. Well, we have a great panel here. And just to give you a sense, a roadmap of where we're going to head in the webinar, we're going to focus on PG&E's experience with digital twins and what they've learned moving beyond the pilot phase. But I think before we do that, it's really important to provide some education around digital twins and how they're applied in the utility industry. And to start doing that, Andrew, I want you to help us out with a definition of digital twins and how they have the potential to really improve grid and asset performance.
Sure. So when we think about a definition of a digital twin, it's really a digital replica of the physical assets and processes and systems of a utility. The concept of a digital twin is pretty familiar to utilities because they're used to GIS maps that identify where a physical asset is located. As we move beyond GIS, talking about a digital twin that really has a reliable vision and view of all the utilities' physical assets that the data can be applied to. When you're moving beyond GIS, you're talking, which is static. You want to interact with the digital twin. It can provide insights that utilities can use to improve everything from planning to operations and maintenance. Ultimately, the digital twin gives utilities the information they need to manage and optimize physical assets and systems. So that answers the first part of your question, Chris. And then the second part is on the application. So when you're talking about application, you're really looking to test the system, right? And that creates optimization. So you want to be able to identify an equipment failure before it happens and perform maintenance to avoid that possibility. So an example of that might be studying impacts of storm events. Another application would be to improve operational efficiency. Digital twins, just like everything, has the ability to have real-time monitoring and control, which can provide valuable information for making decisions about how to operate equipment efficiently. Another application is digital twin is the sort of the test bed for innovative solutions. All utilities have to understand all the changes that are coming at them at once. The digital twin is a way to test these new processes and tools for managing an increasingly complex grid in a risk-free environment. And finally, when we talk about the application of the digital twin, it's really about training and safety. Utilities are most familiar when it comes to the digital twins. When you see these, when you go to the conferences and you see the goggles that you put on, and you're going into the visual or virtual land that you can see the pole and you can look at it, and that becomes an opportunity for training and safety in that you can provide real life simulated scenarios for either the field or for engineers to get training.
Great, thank you. Well, I think that most of our audience members who will already be familiar with digital twins and have been to an industry conference probably have put those goggles on and have a sense of what you're talking about there. Jeremy, I want to bring you into the conversation. A lot of our audience will be very familiar with GIS and probably use it in their day-to-day work. I want you to take that, that understanding and expand a bit to help explain, how a digital twin can really provide a deeper understanding of utilities' physical assets and kind of drive some of the outcomes Andrew was just talking about in terms of anticipating and planning future actions.
Yeah, so kind of building on what Andrew, mentioned, right? GIS, a lot of that data is built in layers. I like to think of it kind of like the slide, right? You've got multiple layers that build on each other that in the end is that ultimate goal, that cap, right? Is that digital twin where you can affect your system without actually affecting your system, right? And so it gives you that holistic view of your data, your assets, your system, whether it's a substation, a factory, whatever it will be. But it allows you to then manage and plan better, right? So whatever devices you have out in the field, you could monitor real time if it's tracking movements or circuits, whatever it might be, and then that helps you manage and plan for all of that monitoring assets that you need, right? So an example would be if you wanted to, monitor a tower or a foundation, whether it's, a buried grillage, if it's a concrete foundation, whatever that asset might be or what you want to monitor there. You want to make sure it's in good shape. You have inspections, you have other areas where, you can check and monitor, and that's important. But where that real benefit of a digital twin comes is that all these extra layers and pieces of information that help build that monitoring system. So instead of always having someone have to go out to the field to monitor, you can have other data. So kind of like Andrew mentioned, storm events, right? That's one area where you can pull in external data to monitor and help track your asset. So a lot of data you can collect around that, right? Is soil, is it easily eroded? Is there a creek or a river or whatever might be around that structure? And then you can grab photos and monitor if there's bigger washouts, or if a storm event did come through, right? You're collecting that data to build that system, right, to monitor and do that. So part of that as well, right, is you build those layers, you can start to anticipate that, right, and say, hey, we've seen erosion at this tower previously in its history, or we know from an inspection that there was a cracked foundation, and now we know that a storm is coming through, and what's going to happen. And so as we build out that anticipation of in the digital world of, hey, what's 100-year storm look like? How many inches of rainfall is going to come? What's the drainage area, and how's that going to affect that? If by chance multiple 100-year storms happen in the same year, right? And so you can kind of look at that and anticipate what's going to happen around this asset, this structure. Is that cracked foundation going to really be exposed? Is corrosion or whatever is going to, seep down and affect the internal rebar of that foundation? Other things like that. So, it really helps you look at where you are in the world and what's going on. So, another aspect, right, is that tower out in the middle of nowhere? How close or how quickly can you repair that structure if it was to fail? And you can build in that extra layer of risk assessment as well, right? Is it located, or is it feeding a critical infrastructure, hospital, whatever it might be? And you need to monitor or track that more frequently. And, if that failure was to happen, what would be the impacts? And that's what that digital twin kind of allows you to play with those data sets and push and manipulate that. And yeah, as we kind of, build those layers, it allows for better planning and maintenance and monitoring of those systems.
Right. Well, Jeremy, I want to ask you a follow-up question. I think most people in the audience will, it's kind of out in the ether at this point about data, and data as it relates to, it could be to AI, it could be to, ML, digital twins in this instance. And you often hear the importance of data quality. And I'd love to have you just walk us through just how important data quality is to the ultimate value of a digital twin.
Yeah, that's a great point. Digital quality accuracy is critical to really poke that system, right? And so a lot of people might have heard, garbage in equals garbage out, as that really applies here. As you look and you comb through that data, if it's not accurate when you apply like that 100-year storm or other things, it just doesn't work right. And so, yeah, it's a critical, huge part of it. And it's all possible based on that data and stuff like that. So, right, that end goal is for that digital twin to meet that, manage that, allow that ability for that utility the ability to manage all of that in one place, right? So, right, that includes that GIS data that we talked about, that we mentioned as kind of that base layer, all of the points here, that permits, the work bundling, quality management, asset health, all of that, right? It's actually kind of surprising. There's a good number of utilities that don't know the exact location of all of their assets out in the field, which is kind of surprising. Whether, a tower replacement happened and, it's off by 20 or 30 feet, or it could be hundreds, right? Or if they took out a line, other things like that. So it's important to utilize and have that data available up and accurate, right? And so, permitting is another area where accuracy can really help, right? Are you on someone's land or other area easements, right? Where do you have to go to get there? Other things like that. So another area that's important for accuracy is work history, right? What has been done on that tower previously? I think we've seen and found that, hey, this tower repeatedly needed repairs. There's probably a bigger underlining issue that we need to go address. And so there's a lot of that, right? And trying to provide that whole picture is important, right? You can take a look at, your own health, right? You can go into a doctor's office and, say, I'm feeling a pain, and they can pull out a chart and it's missing data, maybe your blood pressure, your last physical, other data points, right, about you, did you have your appendix out or not? But that's where I've got pain, right? And so a doctor, unless they have all of that information, right, they can't pinpoint what's wrong. If I say, my side hurts, oh, it's appendicitis, but I've had my appendix out, it can't be that. But if that data point's missing, they can't fully see that. And I think that kind of applies here as well, that if we don't have that data set, accurate, and full, you might miss something important, something small, but it will depend on that. So, when we're engaging with our clients, with Mike and PG&E, really in those early stages, we really do try to verify the data that we have, that they have, to make sure that what we're gathering and what we're building upon is accurate, is correct to the best of our abilities. And really that's what's ensuring that digital twin deliverable end goal is met, and they can be able to utilize it for all of that planning and poking and testing of the system outside of actually testing the system and things like that. So we really do try to pay attention up close early on what data's there, where it's coming from, the data sources, all of that things. So it's almost to a point where inaccurate data could be more hurtful than helpful. It just, if you're making decisions based off of that, you could go replace a perfectly healthy pole and, 3 poles down is the one that's failing because you didn't have the correct data or accuracy there. So it's just kind of a real big waste of time and resources without that accurate data.
Yeah, absolutely. Well, so Andrew, I want to bring you back into the conversation here. In my intro, I talked about how lots of utilities have piloted digital twins and just not been able to kind of cross that chasm and scale. Why is that? What have you observed that are the challenges to moving from pilot to, more widespread deployment?
Sure. There's a couple of reasons for that. I think one is cultural. I think people in general are often wary of change. They're used to how they're doing things, and they're comfortable there, and are resistant to anything that gets in their way. Another item would be data silos. Not just silos, but they're in differing formats as well. That can limit the access or sharing data between different groups. And I think pilots are inherently limited in their scope. They're developed to fix a particular problem, and then when you're expanding into other systems or other upper operational areas, they don't have that organizational buy-in that you've from the solution of a small single workflow process. The other item is establishing the necessary workflows to get accurate data in a consistent format from the field into a digital twin can be straightforward on a pilot scale. You're training one person to use a new piece of equipment, whether it be a camera or a tool to digitally deliver information, and you may be training one person to receive that data. But when you're talking about expanding that into hundreds of people, it's a much different process, and that goes to resources are also precious at a pilot scale. It's not typically a problem, but it can be when you're going to scale.
Yeah, absolutely. Well, so that's a pretty long menu list of challenges. It begs the question, what can be done? Andrew, can you walk us through some approaches that can help tackle some of those challenges?
Sure. Yeah, I think one that Mike has really done at PG&E is the intentional and thoughtful change management. You get people's perspectives, solicit feedback early on in the process, and you're surprised what you can get. And the people actually can buy into the benefits that they'll see, and they're supportive in the adoption as well. You also have to be honest about what scale means from a workload perspective. It's not hard to ensure accuracy of quality of data when you're using a small subset, but processing and cleaning system-wide data is something a little bit different. We like to put an emphasis on ensuring comprehensive data accuracy in digital twins. We do that by verifying the data accurately reflects real-world conditions. This can involve site visits, photograph, and then cross-referencing maintenance logs. At EKN, we also see overcoming the challenge of data silos that limit its scalability by creating central repository so that data can be shared between groups, unifying a system of record. That creates the central system or source of truth where a utility, or all asset-related data is verified in the same format. A digital twin is never a finished product. It's constant maintenance and updating, just like the assets themselves. And then finally, you have to tackle. When I talked about resource limitations, you always want to work towards the highest and best use. Something that we've experienced from an engineering perspective is you want them to always be doing engineering tasks. That means you can automate and delegate as many of those administrative and data coordination tasks off to a different source other than engineering.
Right. Okay, so that's a good foundation in digital twins and some of the opportunities and challenges and issues that need to be navigated. Mike, we're going to bring you into the conversation to learn about your experience with digital twins. And you've been able to move from pilot phase to something more. And I'd like to start with having you explain, prior to this engagement with EKN, how did PG&E view digital twins, and were there any digital twin initiatives that you saw to completion?
Well, I think in the transmission environment, and given the industry tools that are available to us, most utilities do work in a 3D environment. And when we talk about digital twin, we often connect that to, 3D view, 3D design. So that's essential in the transmission world. And our experience with creating models that represented a certain circuit or a project was pretty significant. We knew how to do it, and I think most utilities do. I think the aspect of that really changes it from a simple 3D model to a digital twin is the applications, processes, and governance that you put around the usage. And I think Andrew happened to hit it right on the head with managing it through the change process, the cultural change it takes to do that, the dedication you have to, abandon your paper drawings and train your entire organization to look at assets a different way. So it really is centered around commitment, putting your toe in the water and saying, let's try this or let's try that is not the approach we took. We had plenty of experience modeling. The problem is we didn't have a way of managing the data in and out of the model. Once you create a model, it's relatively worthless unless you maintain it. And we created applications that work along with our design software that manage the transfer of that data and the processes related to that data. And that's really, really important to keeping the model fresh and to keeping the model trued up to what exists in reality in the field. So it's all about your commitment, I think. We found that we were utilizing drone photography for our inspections, gave us a great resource, gave us a great view of all of our assets. And we're also utilizing LiDAR for our vegetation management commitment. And we leveraged that to begin modeling the entire system. So between those two bits of information, which quite frankly, we didn't pay anything for, they're all covered already by other aspects of the company. We leveraged that information with the applications we built to create digital models as we execute work. So we don't really, we didn't stop everything, build a model, and then restart. We're building it as we go. We did a study of our fire tiers recently for all clearance deviations. And as part of that study, represented about 40% of our system. As part of that study, we built models as we did that evaluation. It's a necessary step for the evaluation. And the model now is available to us for every other possible use we want to apply to it, for consideration for alternative designs, for further compliance evaluations, and I could go on, and also available to other stakeholders. But still, it is not very useful unless you have the system in place to track your model through your as-built process, through your project design process, and all the other processes that might touch that asset or change it. So it's important that all these processes are in place and solid before you make a change.
Right. Can you just take a minute and talk about the specific objectives that you had with the work with Andrew and Jeremy around the towers, just so we can define kind of the outcome you were driving towards with some of the, processes and cultural change you just went through?
Yeah, I think, a high level of objective was really safety at two levels. If we don't have to send someone out in the field, that's a safety win for us. And being able to work in a digital environment that's representative of what is in the field is a tremendous benefit to safety. The other aspect of safety is certainly public safety in that we now have models we can use for predictive analysis. And that's a lot of what Jeremy does for us. We had, we just came through rainy season recently, and Jeremy was able to take a look at burn scars associated with prior fires. So here we have one tragedy potentially leading to another tragedy where high runoff from burn scar areas could erode our towers and cause damage. And we were able to use the terrain models and identify areas where maybe we had poorly graded access roads or drainage paths that used to exist that no longer existed, and just overall a poor situation, poor locations of towers. And we were able to get out in front of that, identify those locations, remediate them, and can't tell you that a tragedy would have occurred, but I do know that we spent the time and money to mitigate the risk there. So that's a kind of a small example of how we're using the digital twin.
Right. Well, you spoke earlier about, sounds like the skills around 3D modeling were very much in place, and there was more of a cultural and maybe workflow change that had to take place. Can you give any kind of specifics on your change management approach? Like, what were the specific things that you were trying to communicate or institute that kind of moved, built on the skills that you already had to
Sure.
really leverage the benefits of a digital twin?
Sure. Long road there. And at PG&E, I could cite three, and I'm sure most utilities, I could cite for you poor examples and some good examples. Part of our concept was to build tools that help engineers gain efficiency and mostly to boost their confidence that the data they were using was reliable. So data integrity is absolutely essential. If an engineer came across something and said, well, this isn't right, I know that for a fact, this information needs to be verified, we developed a process or a system where they could report up those kind of findings and we can get that information verified. So now they had a feedback path, right? And that improved their level of comfort. They weren't simply being fed information and directed to use it. No engineer wants to hear that. So in designing processes and including feedback loops from not only our engineers, but from our construction folks as well, we're able to boost confidence and trust in the data we are creating, in the models that we're creating. And that's essential. You can't just roll something out, take the wrapper off and say, we're using this from this day forward. That'll never work. It's been tried and it's just not going to happen. Engineers are not going to buy into that unless they have a high level of confidence in how it performs and the integrity of the data that goes into it. So building that, and we started off small. We started off with basic process tools just to get them accustomed to going through a process app, answering checklist questions, kind of training them on what the future would look like in processing information. Whether it be through our work verification process, a project as built, processes like that were simple enough for the engineer to understand and transition to easily. we've moved on now to more complex processes that deal with checking in the models, checking out the models, maintaining the models, connecting the models to our milestone project progress, such that when a model is checked back in, there's meaning to it. There's a set of criteria that are met before a model can be checked back in. And then others can rely on that model, knowing that it's at a certain milestone. So creating those important integrity aspects as you go is important and essential to building up the confidence of your engineers. But there's no replacement for that. You know, I attended a meeting recently, just anecdotally, where our substation folks said, we're going to move to a new software platform, and all of our substations are going to be digital, and there's going to be no more paper prints. Well, I thought there was going to be a riot with our systems test folks who are totally dependent on those paper documents located at every substation and all the markups that go on those paper documents. So the substation design team just failed to recognize that that was a resource for that team. That's a resource you need to substitute if you want to make a change happen in the digital world. So they got to rewind that back and rethink it and roll out the tool, the look, the feel, and the integrity first, then make the change to process, then make the change to how the models can be used and the integrity behind the data.
Have you noticed, I mean, it sounds like you have, because the engineers and other people who will be using the models have been involved throughout the entire process and continue to elevate the models and improve them. What's the attitude about the models and their usefulness in their work because of that involvement? Has it been something that is obvious as just enthusiasm? Is there transformation in how they view the value of the digital twins?
It's definitely transformational. Just in something simple as a pole replacement, it's so easy now to analyze adjacent poles and impacts beyond adjacent poles even, that it all happens automatically. It's simple to do. It's you're prompted for it, and there's no additional modeling effort necessary to execute those kinds of checks. Whereas in the past, that might be something an engineer uses their judgment around. Do I really need to do this? Do I need to model adjacent structures or not? It's already there. So you're really getting that evaluation whether you asked for it or not, and it's getting you to a decision point faster. So it's really been a tremendous efficiency gain over using raw LiDAR, and it's probably reduced our pole design time by in excess of 30%. And for designing 3,000 poles a year, that's not insignificant.
Right. Okay, I have a couple more questions, then we're going to switch into a few questions from the audience. You mentioned stakeholders earlier across PG&E, and how have they? I don't know. I guess maybe it's a two-part question. How have the digital twins gotten kind of the buy-in that you've seen with the engineers across the organization, and are you seeing the digital twins being used, sort of across PG&E for, maybe even applications you hadn't imagined?
Well, the last part of that is we're imagining a lot of things now, but the usage beyond engineering is somewhat limited, but extremely valuable. And keep in mind, a lot of times we get stuck on the definition of a digital twin and we're thinking, oh, it's all about the physical assets. It's not. The information about work in flight, what's being designed, who's designing it, when is it going to be constructed, is it planned for the future, is this project impacted by a solar installation customer? All of this information is part of the digital twin. And it's really becoming valuable to folks like our wireless program who are leasing out locations for antennas, but now they have visibility into where a project stands. Is this facility going to get replaced in a few years? Is it designated for maintenance work, which might impact the leasing of that location? Is it a joint pole where there's already other users on that facility? So some of the information is about the physical assets, but there's a lot of information about the obligations around that pole, the maintenance obligations, the inclusion of the asset in a portfolio of work, whether that be our maintenance portfolio or our project portfolio, or maybe some other stakeholder portfolio like our corrosion program. So creating visibility of the assets in time, in real time, and maintaining that is what we're finding out to be the real value that we can bring outside of the engineering group to other stakeholders.
Sure. Okay, last question for audience Q&A, and that is, we have an audience here, and there will be people, I guarantee, who maybe got stuck in the pilot phase and want to know what can get them unstuck. And I'm curious, from your own experience, what are one or two best practices that can really help facilitate this process and facilitate, the benefits that digital twin can deliver to a utility and its customers?
I think, what we tried to avoid here is trying to get that funding to build the entire system. It's never going to happen that way. There isn't those kinds of dollars available in today's environment. So you have to leverage what is on your plate already to get an improvement like this done. And I explained how we were fortunate to have access to system-wide LiDAR data, and we actually applied for a Department of Energy grant this past year and received the grant to enhance that LiDAR. So now we're getting more detailed information, which is going to only expedite our model creation. And we are looking at model creation in advance of project work. We will make the decision to model an entire circuit if we have a significant amount of project work on that circuit. So we're leveraging the work that's coming our way, the new customers that want to be onboarded, the reliability work that we're executing. We're leveraging all of that to create models as we go. And that becomes difficult or wasteful if you don't have those processes already in place to maintain. You need to decide on how you're going to manage your data. You need to decide on strict governance around your processes for work flowing through your milestones, flowing from your contractors. We have a lot of contractors that do work on our system, and they need to be on board with the same processes. And that's why process is so important. And once you establish those processes, you have good governance around them, digital twin contributions can flow in as work is executed. And there's nothing wrong with that. There may be an opportunity to expand that at some point with some funding, but it's still contributing in a major way to creation of the digital twin. So at PG&E, we probably have well over half of our transmission system modeled, both towers and poles. But we expect to accelerate that over the next few years and complete the entire system.
Right. Well, we could keep going and lots more questions, but we're going to shift to just a couple of audience questions. Mike, you're going to have to stick with us for just a second. You were sort of getting at this question from the audience already. What are PG&E's future digital twin plans to kind of extend where you were headed there, modeling the whole system? What is there a roadmap?
Yeah, there's a roadmap, and this is the secret plan here I'm going to reveal. So we've one of the benefits about building a digital twin is once you build it, and if you maintain it, and by maintain it I mean update it when you make changes to the system, there's really no need to obtain LiDAR for your system ever again. We spend a lot of money on system LiDAR, and we are going to repurpose those dollars into a change detection program. So change detection is probably 10 to 20% of the cost of all new LiDAR, where you're just obtaining raw point cloud data and comparing it to your prior point cloud and directing your attention to things that have changed, right? Change detection. And this will be our system going forward. This is how we will maintain the models, true up the models to changes beyond our system that have taken place. A new road's been constructed. Some grading's taken place. An apartment building has been constructed. All these things that might influence our system, we're going to pick up on during the change detection process. And again, update our model accordingly. So that's going to represent a pretty significant cost savings to us going forward. And we're going to redirect that cost savings to more model creation until we have the whole system completed. So that's kind of our future. We're probably, looking at a 5-year program or that ballpark to get the entire system done. But that's our plan.
Great. Well, we have time for one more question. Jeremy or Andrew or both, you can tackle this. It's interesting. We just heard about a pretty advanced view of digital twin plans and how that future looks at PG&E. This question is at the other end, and that's around what's the first step that a utility should take to explore the possibility of a digital twin program, or really, what's an action item to take away for those who are at the beginning rather than well into the digital twin journey? Jeremy, do you want to take that, or both of you want to take a stab at it?
Well, I'll take a shot at it first.
I can go ahead a little. Right, I think. Oh yeah, I think a a lot of it is defining some goals, what you want to achieve with it, because I think as you're starting off, it's kind of overwhelming, right? There's a lot of information out there. Mike has talked about a lot of the extra information beyond just that, 3D model, right? A lot of other dimensions. And so I think having a goal in mind of where you want to end so you don't change as you go as often is really helpful in those first steps, because then, that as you start to collect that data, what's out there, right? Seeing what's available, I think one of the big keys, I think, to the success, like Mike was saying, is they had already all of this other data out there that could be utilized without having to put forth a lot of resources towards it. And so looking to see what you've got. What is your data set that you're starting with? I think those are two beginning steps. I think that if you're looking to start this process or switch from your pilot into a full program, that can help with that. I know there's probably a lot of other advice, Mike or Andrew, that they might have as well. But from my point of view and how we've seen it, I think those are two things that I think are helpful.
I think my advice would be you probably have access to a lot more data than you think you do. And it really, to me, starts with data integrity. Take a look at the data you're relying on or your people are relying on. When someone goes out to the field, what information are they sourcing to understand what they're going to be confronted with in the field, or what components they might bring with them to make a repair, etc. So understanding where there are reliability gaps in your data and working to close those. Most design work in today's world is done in a graphic works design format. And from that format comes a lot of digital information that many utility companies don't place a value on or have not leveraged. But that's a very easy step to take. You're already paying for that. You already have access to it. Leverage it into your current system of record and start to improve the integrity of the data that's there. That's probably the number one complaint I got from my engineering team and from our construction folks as well. I can't use that data source because it's just not reliable, and I can't put someone in an unsafe situation. So they bypass the data source and they go back to the tried and true method of seeing it in the field and executing it the same way that they used to. So I think data integrity, exploring the data that you have access to already, and leveraging that into a maintenance process for your data. And I think that's foundational.
Yeah. Andrew, anything else?
Well, I think Mike took my biggest point, but I'll just add on to a little bit. I don't think there's ever been an initiative that we've worked through where we didn't think, hey, we shouldn't have gotten change management involved this early. I think the earlier that you do that, the better, right? Find a subject matter expert in whatever you're looking to change. Get them involved. Let them bring along others and solicit feedback. And before you know it, you're gonna have widespread adoption.
I have to agree with that. The change management attention we've gotten from your team, Andrew, has been invaluable, mostly because they listen. And leadership folks may find it difficult to listen. But when we hear from your change management team that, hey, this isn't working, or there's a lack of understanding, or this gap needs to be filled, that's really helpful to our team. We don't always have our finger on the pulse of the design team and their feedback. And, the change management team fills that gap for us, and it's been very successful.
Terrific. Well, that's a great discussion, and that's the time we have today. I want to thank our great speakers today, Mike, Andrew, and Jeremy. We really appreciate all of your insights and the value of your experience. And I also want to thank the audience. Thank you for joining us today. Hope you got a lot of insights out of this and best practices to go apply to your own work. And we hope to see you again at another webinar, and have a great day.